Okay, so today we are going to learn about polynomials. We are going to be doing a lot of things with polynomials within the next two chapters. First, in this chapter 6, we're going to learn about them, then we're going to learn how to add and subtract them, we're going to learn how to multiply them and divide them. Then in the next chapter, we're going to undo everything and work backwards from the answers, and then then it'll look like the questions that we see in 6.3. So go with our polynomials. Here it's just reviewing some skills, and notice on number 8 this is a mistake, so we can skip this one. But on numbers 1 through 4, all you're doing is evaluating the expression. They're giving you the value of x, so we're substituting like we've done all along here, and we're replacing x with the value. So for number 1, you'll take 2x plus 3, take out the letter x, and in it you're going to put the number 7, and then you're going to follow PEMDAS. And then we get, I'm sorry, that the answer is 7, sorry. So we're replacing x with a 2, and then get 4 plus 3, and the answer is 7. All right, so that's all you're doing on the beginning part. We did a lot of practice of substituting in values when we did the lesson on substitution and elimination. Now, a coefficient, if you don't remember this from middle school, a coefficient is just the number that's in front of the variable. And if there's not a number there, you assume it's got a 1 in front. So for number 5, the number that's in front of the x to the third power is 4, and that's what they wrote as the answer. The number in front of the n to the 7th power is a 2, so that is our coefficient. Yes?
For number 4 in the warm-up, it says that the answer for that is 69.
Okay, so let's try it. Let's see if they've made a mistake. So you have to follow PEMDAS. So we're going to take and put in 3 for the x, and there's 2 of them in here. So when I do this, I don't multiply this first. I need to evaluate the exponent first. So 3 squared is 9. And then over here, I can just rewrite this. Now I'm going to multiply. 7 times 9 is 63, plus 2 times 3, which is 6, gives me 69. So common mistake, people would be tempted to multiply this first, which would not be following PEMDAS. So we have to do the exponent first. Then notice on number 6, it doesn't have a number in front, but I can assume that there is a 1 in front of that y, and that's the coefficient. Right. Number 8, the coefficient should have been -1. Okay, so number 8 was a mistake. The coefficient here is -1. All right. Okay, so in this lesson, we're going to be classifying polynomials. We're going to learn how to write polynomials in standard form, and then we're also going to evaluate polynomial expressions. Question?
Yes. Well, not a question, but they also made a mistake on number 8.
So this is our vocabulary that we're going to see in this lesson. On the test on Friday, a week from today, you're going to have to identify and give the name, whether it's a monomial, a binomial, or a trinomial. And you're also going to have to give the degree. You're going to have to put it in standard form, give the leading coefficient, and then give the name of the polynomial. And we're going to see all of this in this lesson. So here is an example of what a monomial is. A monomial could be a number. It could be a variable. It could be a product of numbers and variables. It will also have only whole number exponents. So we're not going to have fraction exponents or negative exponents. So only positive whole number exponents.
So only positive exponents?
Correct. Make something a monomial. the degree of the monomial is going to be the sum of the exponents of the variables. A constant has a degree of 0. Now, don't get confused and think that the degree is the exponent on the number. It's only the exponent on the letters. So, technically, the exponent on this 5 is 1, but the degree on the 5 would be 0. So just know the difference. Now, in this side of my box here, these are all examples of not monomials. Notice this has a negative exponent. Here, we're adding and subtracting 2 letters and a number. And here, there's a fraction and there's a letter in the bottom. So you cannot have a variable in the bottom of a fraction. You cannot have a negative exponent. You can't add or subtract 2 things. Those would not be monomials. So let's go through a couple of examples. And I'm going to write something on here, and you're going to tell me yes or no if it's a monomial. So the number 5, is that a monomial?
Yes.
Yes. Then the letter A, is that a monomial?
Yes.
Yes. Can I have A, B together?
Yeah.
Yes. It can be a product. So you could have 2 letters next to each other. What about 5 to the negative 2 power?
No.
No. You can't have a negative exponent. What if you have 5 over x?
No.
No. No variables in the bottom. What if you have x plus y?
No.
No. You cannot add 2 letters. You can only multiply them. You can't divide them either. So you couldn't have x over y. So this is no, this is no, this is no, this is no. So know what a monomial is. All right, now when you have variables, the degree is the exponent. So the degree of x squared is going to be 2. Okay, now also, if you have more than 1 letter, you're going to take all of the exponents and add them, and that will give you the degree. If your variable does not have a number, remember you're assuming there's a 1 here. So 1 plus 1. So the degree is the exponent. If your letter doesn't have a little number up there for an exponent, assume that there is this little 1 that's understood. And then 1 plus 1 is 2. Remember, if you don't have any letters and it's just a constant, the degree is 0. You will have to give the degree of a monomial on the test on Friday. Now, when we talk about the vocabulary word terms, that is going to be what's being added or subtracted. So when I have an x plus y, x is one term and y is the other term. So this is getting us ready for combining like terms, which we did in chapter 1. But basically when we add and subtract polynomials, all we're doing is combining like terms. So I would look for any x's, any y's, and then group them all together. So here is some practice for finding the degree. Now notice on question for part A, we can assume that the m has a 1 here. So then when I go to find the degree, I'm going to add 2 plus 1, and my degree is 3. For part B, the x doesn't have a number, but remember you're assuming a 1, so the degree is 1. And then for part C, the letter C has an exponent of 3, so the degree is 3. Let's do a couple examples. What if I have x to the 4th, y to the 3rd?
7.
Okay, let's raise our hands. So then the next one, what if I have, all right, What would be the degree of this monomial, Carlos?
1.
Good. Okay, there's not a number there, but you assume it's a 1. What if I have 5x, y, z? What is my degree, Cyril?
3.
3. Remember, each one of these letters has a 1 there. But you getting the idea for finding the degree? All you do is add the exponents. What if I have this? What if I have 100? What's the degree of 100? Vincent?
0.
0. When it's just a number, the degree is 0. Good. Let's go on. So now we're going to get the definition of a polynomial. And a polynomial is a monomial or a sum or the difference of monomials. The degree of the polynomial is going to be the degree of the term with the greatest degree. So when we're finding the degree of a polynomial, we're not going to find the degree of each term and then add them up. We're just looking for the biggest number. So a polynomial could be a monomial. It could be more than one. So like the sum or difference, this means I'm adding two polynomials or two monomials, and this is a polynomial. The prefix poly from your vocab means many. So I have more than one monomial and it makes it poly. So if I add two monomials or subtract, this turns into a polynomial. Now you can have 3 or 4 or 5 or 6. These are all polynomials because we're adding or subtracting some monomials. Does that make sense? All right. Now, to find the degree, you're going to find each one of the degrees separately and then look for the biggest number. So I'm going to go through each one of the terms of this one right here. So first of all, what is the degree of my x squared?
2.
Okay, that one's got a 2. What's the degree of the 5x?
1.
Okay, what is the degree of the y?
Is it 1 or negative 1?
It's 1. The coefficient is -1. But the degree, remember, we look at the exponent.
Okay.
All right, and then the z also has 1. Now that you've identified each separate term's degree, we look for the biggest number. What's my biggest number here?
2.
The 2. So the degree of this polynomial would be 2. I don't go and add until the degree is 5. I look for the largest number. And we're going to do some examples of these. Okay, so here we go. We have some polynomials here. And I have two terms on part A. I have the 11x to the 7th. And I have the 3x to the 3rd. So I can see that my degree for this term is going to be 7 because the exponent on the x is a 7. Then I can see the degree on this one, or the exponent on this one, is a 3. Which number is bigger, 7 or 3?
7.
So the bigger number is the 7. So the degree for this polynomial is 7. Do not add them. Look for the biggest number. Everybody understanding what I just said? All right. Again, you're going to repeat the process. Look for the degree of this term. Remember, the z has an assumed 1. So 2 plus 1 is 3. And then do the degree for this one. This one has only one exponent here. It's a 4. And then you look for the biggest number because the 5 has a degree of 0. So the biggest number here is the 4, and that is your degree. Okay, let's look at this one. What is the degree of this term? Cyril?
1.
1. What's the degree of the -6? Carlos?
0.
0. What number's bigger, 0 or 1?
1.
Okay, 1. So the degree here is 1. Let's look at the next example. We got to do a little bit more work on this one. All right, let's look at this term first. Okay, what is the degree Vincent, of this one?
5.
5. Okay, let's shift over to this one. What's the degree of this term, Joshua?
5.
Okay, this one's a 5 also. Okay, let's shift over to the next one. What is the degree of the x to the 4th? Joshua?
4.
4. What's the degree of the 2? 0. Okay, now I'm going to go back and I'm going to look at all the numbers I've written down. What is my largest number?
5.
So the degree of this entire polynomial is 5. Again, do not add them. Look for the biggest number, and that is the degree. All right. Now we're going to learn about standard form of a polynomial. Basically, all you're doing is writing it from greatest degree to the least degree. So you look for the biggest exponent and write it in descending order. So if you had an x to the 5th, you would write that first, then 4, then 3, then 2, and then the constant. Okay, the leading coefficient is going to be the first number. Okay, can you guys remember back to when you were in pre-K? Okay, and you had jobs in pre-K. You guys remember that?
Yeah.
Okay, do you guys remember being the line leader in pre-K? Yes, or in kindergarten?
Yeah.
Okay, what did the line leader do? They led the line, so they were the first person in the line. So when I talk about a leading coefficient, I'm looking for the first number in my row of numbers and letters. That's the leading coefficient. He's the line leader for the polynomial. Okay, so here we go. We have a polynomial here. We want to put this thing in standard form. Okay, I'm not looking at the coefficients. I'm looking at the exponents. And I want to put this in order from greatest to least based on the exponents. So looking at my polynomial, which exponent or which term has the biggest exponent? Carlos.
Negative 7x to the 5th power.
Perfect. Now, when you go to rearrange this, you're pulling the sign that's in front of that term. So this is going to be my first term. Okay, now looking at the 6x, the 4x squared, and the 9, which one has the next, or the next one down? Vincent.
4x squared.
Good. So this is going to be number 2. And then after that, what would be next? Cyril.
6x.
The 6x. And then the constant, or the number that does not have a letter, always goes last. And this is how you put something in standard form. So now we're going to rewrite it. So I'm going to take the negative 7x to the 5th first. Then I'm going to write the 4x squared with the sign that's right in front of it. Then I write the 6x, and then last, the constant. And my polynomial is now in standard form. So greatest to least based on the exponents. And my line leader here is going to be the number negative 7. So it's whatever's out in front. It's the coefficient. So it's not the exponent. It's the coefficient. So the number that's the first thing that you've written is the leading coefficient. You will have to do this on the test next Friday. You will have to write it in descending order based on exponents and also identify the leading coefficient. All right, here's another example. Again, what is my largest exponent here? Carlos.
6.
Okay, so the y to the 6 is the biggest, the 6 is the biggest exponent. What would come second in this polynomial? Cyril?
Y second power.
Good. Y to the second power. And then last, we didn't have a constant. but in order from least to greatest, then comes the negative 3y. So again, let's rewrite it. So I'm going to take the letter that's in front, or the sign in front. So it's y to the 6th. Then I'm going to do the blue. And then lastly, the green. And it's in standard form. What number do I assume in front of that y to the 6th if there's nothing there? A 1. So my leading coefficient here is equal to 1, my line leader. Good? All right. Now, here they're actually explaining to you that when you have a variable without a coefficient, it's got a coefficient of 1. And that's what we just saw when we put that problem in standard form. Okay, here's another example. Okay, what is our largest exponent here?
5.
The x to the 5th. Good. So this is going to be term number 1. What's the next biggest one? Raise your hand. Somebody I haven't heard from. What's my next biggest number here? My next biggest exponent. Diego.
9x to the power of 3.
Good. This is going to be number 2. What's going to come next? Ballroom.
4x to the power of 2.
Good. So that's going to come next. That's going to be number 3. And then process of elimination, the only thing that's left will be the 16. And that's going to be the constant, and it's our caboose. Okay? He's the last one in the line. Okay? So here we go. We're going to rewrite it. I'm going to put the 9x to the 3rd. The x to the 5th first, the red one. Then I'm going to put the 9x to the 3rd. Then I'm going to put the negative 4x squared. And lastly, the 16. And now my equation is in standard form. And now I can also find my leading coefficient. Okay, somebody I haven't heard from. What's my leading coefficient here? What's my line leader? Christiana. A 1. Remember, you assume a 1. There's a red 1 here. So my leading coefficient is a 1. Now, let's go back. Let's find the degree of this polynomial. Do we really have to do a whole lot of work when it's just a single letter here and it's in standard form? What's going to be my degree of this thing? Carlos?
5.
5. It's sitting right here. Now, if some of the terms had an x and a y and a z or something, where you had to add them, but if it's in standard form and it's only got one letter, then it's going to be that first term. Everybody see that? Made it kind of easy when you put it in standard form. Okay, here's another example. Again, we're putting it in standard form. So again, which one is my largest exponent here? Somebody I haven't heard from. This is easy stuff here. Alejandro. Negative 3y to the 8. Good, that's number 1. What's number 2? Ryan.
18y to the 5th.
Good, the 18y to the 5th. And then the last term by process of elimination, Carlos.
14y.
Beautiful. Okay, it's now ready to be ordered and rewritten. So I'm going to write the red one, negative 3y to the 8. Then I'm going to write the blue one. And then I'm going to write the green one. What is my leading coefficient? Somebody I haven't heard from. Who's my line leader?
Negative 3y.
Okay, so the negative 3 is the leading coefficient. We're only giving the number. What's the degree of this polynomial? Somebody I haven't heard from. Emily. 8. Beautiful. This is easy stuff, right, guys? All right. We're going to get into the naming now. Yes, Vincent.
I have a question. Why is 2 quadratic?
Okay, so whenever you have an exponent of 2, it's going to be a quadratic function. Okay, so what you're going to be doing a lot of coming up are quadratic equations. So all of our equations are going to have an x squared or a variable squared. So the degree, remember, is the exponent. So on the test on Friday, I'm going to ask you to name based on the number of terms. So this is where I was talking about the bicycle and the tricycle. So when there's one term, it's called a monomial. When there's two terms, like an x plus y or x minus 2, these are two terms. They will be separated by a plus sign or a minus sign, an addition or subtraction. Think of a two-wheel thing, which is a bicycle, bi, and a binomial, two terms. When you have three terms, let's say it's x plus y plus z, three terms, think of the three-wheeled thing, which is the tricycle. The trinomial has three terms. The tricycle has three wheels. So a little trick to help you remember the tri and the bi. Okay, yes?
So, x minus 2 is a binomial.
Yes. So these right here are binomials. This one is the trinomial. So when there's three, it's tri. When there's two, it's binomial. So when there's one, it's monomial. And when there's four or more, it's called polynomial. Now, technically, the binomial is also a polynomial, and so is the trinomial. So technically, you could say all of these are polynomials, but anytime you have four or more terms, it doesn't have a special name like binomial and trinomial. You just say it's poly. Now, the other thing we have to do is name it based on its degree. So when you have just a number, this is a constant. When you have just a degree, like an x, this is linear. When you have an x squared, next term here is the x squared, and it's quadratic. When you have a variable to the third degree or the third exponent, it's cubic. And when you have something to the fourth power, it's quartic. And to the fifth power is quintic. Anything bigger than that, you would just say the sixth degree, seventh degree, and so on. So you'll have to base it on the exponent, which is the degree. So let's look at some examples of these. So here's our first one. Let's first base it on how many terms I have.
What if you have like two in the same equation?
What do you mean two?
Like if you have two
Letters?
yeah.
Then you would add, then you would find, you're going to find the biggest degree. All right, so in this case, what is the name for this one? Is this a monomial, a binomial, a trinomial, or a polynomial? Cyril?
Binomial?
It's a binomial. We have two things here. Okay, what is the degree of this term? Vincent?
Cubic.
Okay, this one's to the third. This is a third degree, and this is the first degree. So based on the biggest number, it's a 3, and it's cubic. Good. Okay, so then now, let's see. Let's look at, this one. How many terms are here, Carlos?
4.
Okay, making it what?
Making it a polynomial.
Good. Anything 4 or bigger is just poly. Okay, what is the degree of this thing? Vincent?
6.
Okay, making it, what's the name for a 6th degree polynomial?
It's just a 6.
Yes, it's just a 6th degree polynomial. That was like a trick question. So anything bigger than 5, they just say whatever number it is. Okay, let's look at the next one. The 2x, the negative 2x. How many terms we got here? Joshua? 1. Making it a?
Linear.
Okay, it's linear because it has a degree of 1. And what's the name based on the terms? Monomial, binomial or trinomial? What was it? Monomial. Good. All right. So you will have to do this on the test next week. You will have to give these two names over here. And you would say if it's two terms, it's a binomial, and if it has a degree of 3, it's cubic. Vincent?
Is that what we're doing in homework?
Yes.
Yes, sir.
And putting it in standard form also. All right, let's look at this one. So, how many terms we got here? Carlos?
4.
Okay. What is a 4-term name?
Polynomial.
Good. What's the third degree name? Cyril?
Cubic.
Good. Okay. When it's just a number, is that a monomial, binomial, or trinomial? Just one single thing here. What is this called? Vincent? Monomial. What's its degree?
0.
Okay. Which makes it what word?
Constant.
Good. All right. How many terms are here, and what's the name for it, Carlos?
There are 3 terms, and it's called a trinomial.
Good. And then, what's the degree, Carlos?
8.
And the name?
And the name is the 8th degree.
Good. Remember, anything 5 or bigger than 5 is just whatever the number is. Good. Okay. We do have an application problem. So here we have the word problem. They're giving us an equation. Basically, all we're doing is taking the equation in our word problem and taking out the letter t and replacing it. The t is the time, and putting a 3 in there. And then follow PEMDAS. So we would have to square the 3 first, then multiply it by the negative 16, and then add the 220. Now, this is a classic example that you would probably see on the SAT. There are a lot of word problems based on quadratic functions. Remember, quadratic means an exponent of 2. So they're always having word problems where the quadratic function will simulate what happens. A lot of times it might be a fountain, and the shape that the water makes is a quadratic function. Or when you kick a ball, like a soccer ball, into the air, the motion of the ball as it goes up and then it falls to the ground is a quadratic function. So many of the word problems on the SAT are dealing with these quadratic functions. Here they're actually interpreting the results. So they're saying after 3 seconds, the lip balm will be 76 feet from the water. So she's dropping it off the Golden Gate Bridge, and this is what happens after 3 seconds. Here is another one with a firework. So it's saying that it's got a 5-second fuse, it's launched, and it gives it its speed. Again, they're going to give you the formula to calculate how high. Again, the T represents time, and then you would replace whatever the time they give you. In this time, it's a 5 seconds. So after 5 seconds, the firework height would be 1,606. And here we go. It's just writing the answer as a sentence. So here is a few more examples. However, in the homework, you're going to be looking for the degree. You're going to be putting it in standard form. You will be asked to give the leading coefficient. You will ask to name the polynomial based on the number of terms, and also give the name based on the degree. You'll be doing all of these skills on the test next Friday. So your homework over the weekend is to complete practice A. We will go over it on Monday, and we will reinforce this lesson on Monday. And then Tuesday, we will begin adding and subtracting polynomials, which is essentially combining like terms. So you'll put all your x's together, all your x squareds together, and then just take the coefficient in front and add and subtract. Any questions?